So in this video, we see some exercises on the use of the solver tool in Excel. Solver is a nice feature of Excel that allows you to solve linear problems with constraints. Exercises are in section 3 of the exercise book. And the first exercise is an extension of the exercise 3.2 that we addressed in our previous videos on data table. So let's solve again the first part of the exercise, and then we see the extension where solver is addressed. So again, our company, we have a company that produces two products, product A and product B. Product A is sold at 8 euros and requires 0.7 hours of the production plant, and the operating cost of the production plant is 5 euro per hour. Product B, we can sell product B at an higher price, 15 euros, but we need an hour to produce it because it's a more articulated product. We know that we can expect to sell 100 pieces of product A, 60 pieces of product B. And then we have also 500 euros of fixed costs. So we have to create a spreadsheet to evaluate the total net profit for a given production, where the given production means how many pieces of product A we produce for a month and how many pieces of product B we produce. Then in the previous exercise on data table, we analyzed how our revenue changes varying the production, and we saw that of course the optimum production is when we produce all the pieces that you can sell. The extension here that we want to consider in our exercise is we have a maximum number of production hours, which is 16 hours per 5 days, times 5 days. And then we have to produce at least 40 pieces for each product. Because assume when we start the production plant, then we have to produce at least 40 pieces. So this constraints on the number of hours does not allow whole possible combinations here of product A and product B. Okay, so let's see how we can solve this problem. So we have to create a table similar to this one, and then we have introduced the constraints. So let's open an empty Excel document. So let's put here product A, product B, amount produced, and let's put two numbers here like 90 and 50. The price per product, let's say the income per product is 8 euros and 15 euros for product A and B respectively. Then we have hours per product, 0.7 and 1. Then we have the maximum number of pieces we can sell, which is 100 for product A and 60 for product B. We can compute the income, costs, net, total net. Let's add here cost per hour, 5, and fixed costs, costs 500. So these are euros, so let's set the format to currency. These are also euros, and also here everything is euros. So we can compute the income is production multiplied by the price per product, and then we drag C2 times C3. Our costs is the amount multiplied by the hours we need for each piece, for each product, multiplied by cost hour, F4. Then we drag, okay, and the net is income minus costs, and then we drag. However, in this solution there is a problem because I'm not taking into account which is the maximum number of pieces that I sell. So here I have to modify the income. I can't take 90 because that is the production. I have to consider the pieces that I sell, that I can sell. So I can use an if. So if B2 is smaller than 100, then I take B2, otherwise 100. Or I can use min B2 semicolon B5. So this will return the minimum between the two. So if B2 is more than 100, I keep B2. If B2 is larger than 100, I take 100. And then Control C, Control V. The total net is the sum between the two nets minus the fixed costs. Okay, so let's put this in orange. This is in green because this is what we want to maximize. Okay. Now we have further constraints, which is max hours is equal 16 times 5. Okay. And then min production is 40. So given this production in B2 and C2, I can compute what is the total number of hours that I will need. To do this, this is equal to B2 multiply by B7 plus C2 multiplied by C7. So you see that for this production I will need 113 hours, which is considerably above the 80 hours I have available for a week. Okay, these are weekly productions. So now we have to try to maximize to find what is the best combination of product A and product B that maximizes the total net, given that we cannot work for more than 80 hours and we need at least 40 pieces for product A and product B. So to do this, we can use the solver tool. So data and solver is on the end of the menu on the right. If solver is not there, you can activate it, file, options, add-ins, Excel add-ins, go, and then you select the solver. In my case, this is in Italian, so it's componente risolutore, aggiuntivo risolutore. So just for to be quicker, I don't give labels to the relevant cells, but similar to what we see with data table and scenario manager, it could be useful to give names to the relevant cells, so it's easier when you create when you use them in the solver tool. So solver, okay. First thing is set objective, so what I want to maximize or minimize, and that's the total net. I want to maximize it by changing variables B2, C2, subject to the constraints, and here I can add them. Okay, it disappeared a bit. So I want the production is larger or equal than the minimum production. Add. Product B is larger or equal than the minimum production. Add. Total number of hours is smaller or equal than the maximum number of hours. There is another constraint on the maximum pieces you can sell, but that is embedded in the formula where you compute the income. So I don't have to use it. Okay, as an alternative, I can compute the income directly multiplying B2 times B3 and C2 times C3, adding a constraint here. Okay. So we can now solve. Okay. I don't know why it disappears continuously. Anyway. So you see this is the solution. I have 40 and 52. The total net is 200. Overall, I have 80 hours. Keep solver solution. Sensitivity, okay. Creates a report a sensitivity report. Sorry, I lost the worksheet. Sorry, solve answers. Sorry, I selected the wrong one. Okay, create a table where you have a summary of what happened. Okay. So you see that the solution is quite straightforward if you think about it, because basically, since product B is the less rewarding, I just want to produce the minimum number of pieces of product A, and then I use all the remaining hours to produce as many pieces as possible of product B. Actually, there is something wrong in the formula that we did. I mean, it's not an error, but there's something that we didn't take into account, which in some cases could be relevant. Add our solution here, product A and product B, must be integer numbers. Okay, because we cannot produce alpha piece of something. So add. Okay, cancel. Okay, so we have this new constraint. So if we solve it, we get the same, exactly the same result. Okay. So now let's consider exercise 3.3. So all these exercises are very similar. We try to do 3.3, 3.4, and 3.5, and then you can try to solve this exercise, the remaining exercises by yourself. So let's now try to solve exercise 3.3. So that's very similar to the previous one. We have two types of golf bags, standard and deluxe. So standard bags generates €9, deluxe bags 15 euros. And in the table here in exercise 3.3, you see what are the working hours required for each production department for the two bags. So you see that the deluxe bag is more remunerative, but of course it needs more time for to produce it. You know that each department can work maximum number of hours per month. So you have in the table here 630 hours for the first one, 600, 700, and 8, and 135. You assume that you can sell all the pieces that you produce. So using solver, we want to compute the monthly production of the two bags that maximize the total profit. Okay, so let's see how we can do it in an empty worksheet. So before we see the solution, let me remind you that there's no one single solution, one single way to solve these problems. There are plenty of possible ways. I'm going to show you how I would do it, how I like to organize my worksheet. I know that Professor Coletti uses a different approach, different structures. They are both equivalent as long as you get, of course, the correct results. Okay, so we have here bags type, deluxe, and sorry, standard, and deluxe. Income for each one, so it is €9 for standard and 15 for the deluxe. Or maybe better, let's move this here, Control X, Control V. Here let's put production, and let's say 1 and 1, one piece of standard bags and one deluxe bag. Then we have all the departments. I use acronyms just to do it quicker. Finishing and inspection and package. So this is 0.7, 0.5, 1, 0.1, and this is 2, 0.83, 0.67, and 0.25. Okay, so we can compute now here the totals, let's say. Okay, so we can compute the total income given the production. So to do this, we can do production of standard bags multiplied by the income per standard bag plus production of the lux bag multiplied by the income of the lux bag. So similar as before, if you want to do it quicker, you can use the sum product function. So sum product returns the sum of the products of two ranges of cells. So equal sum product. First array is the production, absolute values, because I want to copy it. And the second one is the income. Okay, so this is currency. Then if I drag the formula, I can compute the total amount of hours for each department given the production in column in cells B2 and B3. Okay, so this is the total that I want to maximize. Okay, these are my variables. Okay, and these are the amount of hours that must be subject to the constraints. And the constraints are in the exercise, so it's 6 and 30. Sorry, these are not currency because I dragged, so number 630, 600, 708, 135. So these are my constraints. So I made them in red. Okay. At this point, using solver, I can find what is the combination of values here that maximizes the cell in green, given that all the cells in orange must be smaller or equal than the cells in red. So data solver. So what I want to maximize is C4 to max. Note that you can also set to a minimum value if it is a cost by changing cell B2 B3. Okay. So let's set the constraints. Add. First of all, I want that cells B2 B3 are larger or equal than 0. In the previous exercise, we didn't have to set this because our minimum value was 40. If you don't have a minimum value, it's good practice to set anyway these constraints, because otherwise you could have solutions for which negative numbers are included, because maybe they reduce the costs are reduced. So first of all, there must be the production must be larger than 0 or equal, and the cells must be integer numbers. And then we want the total number of hours are smaller or equal than the maximum hours allowed. Okay. Let's try to solve this. Okay, so this is the result. 649 standard bags and 87 deluxe bag. And the overall result is 7,146. Let's now consider exercise 3.4. Exercise 3.4 is a little bit different, and also includes a trick, but let's see however. So let's see how we can solve it. So in this exercise, we assume that we have a voucher worth €2 to spend in chocolate. So we go to our chocolate dealer, and there a small bar which weighs 100 grams costs 17 cents, and the large bar that is 250 grams of chocolates is costs 32 cents. Then there's a special deal, so if you buy 3 small bars, then you get one for free. So what we want to buy as much chocolate as possible using our voucher, and we want to spend every euro, because the shopkeeper doesn't give change for vouchers. So what we want to find is how many small bars and large bars we have to buy to maximize the total number of grams in chocolate. So here the trick is this special deal. So in order to solve it the best way, you can create a very articulated if, or the best way to do it is to create another bar the special deal bar that costs like 3 small bars but weighs like 4. So let's see the solution. Let's open another worksheet. So we have bars, cost, sorry, grams. Let's include, sorry, let's put another column on the left. So we have small bar, large bar, and deal. Okay. So let's assume that we have one of each. So the small bar costs 17 cents and it has 100 grams of chocolates. The large one is 32, that's 250. And the special deal costs like 3 small bars, but it has the grams of 4. Okay, so we can compute the total costs and the total grams equal some product again, F4 semicolon costs. So this compute the total cost. So if I buy one small, one large, and one deal, the total cost will be €1. And then Ctrl C, Ctrl V, sorry, I have to set again to number. And the total number of grams is 101 multiplied by 100 plus 1 multiplied by 250 plus 1 multiplied by 400. My voucher is €2. So we want to modify these cells. So let's put them in yellow to maximize the total grams. Okay. Given that the total cost must be smaller than our voucher, must be equal to our voucher. So data solver, we want to maximize D5 by changing B2 before, subject to constraints, add. So again, the bars must be integer, add. Bars must be positive, larger or equal than 0. Okay. And then add. I don't know why it disappears always. The cost, the total cost must be equal to the voucher. So I want to spend exactly €2. Okay. Solve. Sorry, there you go. Sorry, I don't know why it keeps on disappearing. Anyway, so this is the solution. Too small, too large, and too special deal. Okay, so you see we spend exactly €2 and we have 1,500 grams of chocolate. Okay. Okay. Now, however, I want to show you particular case. So in this exercise, we want to spend exactly €2, but that's not necessarily the best solution. So let's see what happens if, let's select the constraint here on the price, on the total cost, change. We modify it and we set it smaller or equal. So we are happy to lose some money if we get more chocolate. Okay, okay. Solve. So you see that if we spend a little bit less, so €1.98, so we don't buy any small bar but 3 large bars and 2 special deals, we get actually 50 extra grams of chocolate. Okay. Anyway, in this case, the exercise asks to yes, to evaluate the both cases, to spending exactly €2, and then check what happens if you allow spending less than €2. Okay. So final exercise on solver. We have, I said, like another two, but for today, for this video, we can stop to exercise 3.5. This exercise features also some part on data table scenario manager, so you can try to solve it, and then if there are doubts, we can see the solution together. Anyway, let's focus on the solver part. So in this case, we produce hot tubs. So we have again two types, Aquaspa and Hydrolux. And the company purchased prefabricated fiberglass hot tubs, shells, and install a common water pump and the appropriate amount of tubing into each tub. So in the table here, you have for each product the number of hours it takes to install it, the amount of tubing you need in meters, and the profit for each product. The company have 200 pumps, so that over the maximum number of products that can be installed is 200. 1,566 installation hours and 2,180 meters of tubing available. You can sell all the products you produce. Sorry. So what we want to do, we want to find what is the optimal combination of Aquaspa and Hydrolux that maximizes the profit, given that the maximum number of products is 200, the maximum number of installation hours is 1,566, and the total number of tubing is below 2,880. So this is very similar to the previous one. Let's open another worksheet. So again, here we have Hydrolux and Aquaspa. Okay, so products, these are the variables that we want to modify in order to maximize our profit. Then you have installation hours, 9. It's 6 for the Hydrolux and 9 for the Aquaspa. So I swap the rows with respect to the table in the exercise. Tubing. So for the Hydrolux is 16, for the Aquaspa is 12. Profit 350. 300 for the Hydrolux and 350 for the Aquaspa. Okay, totals. So we have the total number of products. This, and then here we have constraints. The total number of hours. Okay, instead of some product, let's see again how we can compute this without some product, but just writing the formula manually. So it's B2 F4 plus C2, times C2 plus B3 F4 times C3. So this is the total number of hours. This is the total number of tubing. And finally, this is the total profit. So this one is in green, is what we want to maximize. These are the values that are constrained to be below our constraints, which are given in the exercise: 200, 1566, 2880. So at this point, we are again ready to solve the exercise with solver, data, solver. So what we want to maximize is E4 by changing B2, B3, constraints, B2, B3, integer, add B2, B3 larger or equal than 0, add B2, B3, sorry, larger or equal than 0, add B2, B4, D4, so our totals, smaller or equal than our constraints. Okay. Solve. Okay. So this is the solution. Home, red. So 68 Hydrolux, 122 Aquaspa. Overall, we have 200 pieces. We work exactly 1566 hours and we use 2712 meters of tubing, which is below the 2880 meters that we have. So to complete our exercises on solver, let's also see exercise 3.7. It wasn't originally in the plans, but since it is a little bit different from the other ones, let's see how we can solve this exercise. So here, basically, our company received a big order. So the company is required to deliver 3,000 pieces of Model 1, 2,000 products of Model 2, 900 products of Model 3. Here in the table, you see that for each model, there are some hours you need in these two units, wiring and harnessing. And however, the company does not have the capacity to produce to fill in the order, to satisfy the order, because the maximum number of wiring hours is 10,000 and the maximum number of harnessing hours is 5,000. So that would not be possible to produce 3,000 pieces of Model 1, 2,000 pieces of Model 2 and 900 pieces of Model 3. However, the company can subcontract the production of some pieces, of some products. So here in the table below, you see that for Model 1, the cost to produce one is 50 euros, 83 for Model 2 and 130 for Model 3. While the cost to buy it is 60, 97, 145. Of course, it is a little bit higher. So in this exercise, we want to find what is the optimum number of pieces to produce with respect to pieces, to products to be bought from the subcontractor, so that we can deliver all the products, minimizing the costs. So this is a little bit different because there's something we want to minimize. So let's see how we can solve this. So Model 1, Model 2, Model 3. Order 3,000, 2,900, sorry. Okay, let's put here to make. So for the moment we put 1, but these are the numbers that we want to change in order to optimize our cost function. To buy is the difference between the order and how many we make. Okay. Then we have wiring hours to 1.5, 3, and harnessing hours 1 to 1. Row borders. Then we have the cost to buy, which is 50, 83, 130, and the cost to make, which is that is the cost to make. The cost to buy is 60, 97, 145. Cost to make, cost to buy. So here we can compute the total number of hours we need for this production. Some product, F4, semicolon, wiring. Then we copy, and also we get here the cost of producing 1, 1, and 1. The cost to buy is, of course, some product again, to buy, cost to buy. Okay, so the total costs that we have to face if we decide basically to outsource everything is the sum between the two costs. Okay, so you see that if I increase, for instance, the production of Model 2, okay, you see that the overall cost decreases. However, I can't produce all the pieces I have been asked to produce because I have constraints here. So the total number of wiring hours is 10,000, total number of harnessing hours is 5,000. So these are the cells that we want to change. This is our cost function that in this case we want to minimize. These are the values subject to the constraints, and these are our constraints. Okay? Constraints. So data solver. So the cell that our objective function is in E9 and we want to minimize it. Sorry, let me delete all these constraints because they were there. I don't know why. Let's create all the constraints. Delete. Delete. So the cells that I want to change are here, B3, D3. And the constraints are B3, D3 must be integer, plus B3, D3 must be larger or equal than 0, and B3, D3 must be smaller or equal than the order. Then the total number of hours in the two departments must be smaller or equal than the total number of hours, the maximum number of hours in the two departments. Okay. Think we can try to solve this. Okay, so basically this is the solution. Basically you have to produce Model 1 and Model 3, while for Model 2 we outsource part two-thirds of almost two-thirds of two-thirds of the production. So you see this is the total cost, and you see that we satisfy the constraints. So with this exercise we conclude our video on the solver tool.